All right, guys, I'm going to be up here.
Hold on, I need to get a pencil, okay?
Okay, get a pencil. Okay, so I want to show you something. Just watch this, okay? Just watch this. Oops. This is a graph. Here is a graph. Okay, it could be the most basic graph in the universe. Which line is this, the Y or the X? Y. Okay, put those arrowheads there. What's this line over here? X. So where's the Y-intercept?
On the Y-axis.
Is it right here or is it right here?
Up there.
Up here?
Yeah.
Y int. What is this point right here? This is the point we're going to learn about today. What is the title of today's paper? Do you see why it's called the x-intercept? It's where it's crossing the x-axis. So last year you probably learned about y int, right? Some of you already knew what that meant. And so today you're going to learn about x int. Your goal today is to find the x-intercept of equations. Okay? So let's put some numbers to this, ladies and gentlemen. Let's say that this is 4, okay? So my y-intercept is at 0, 4. And let's say that my slope is up 2 over 1. We'll make that a big jump, okay? So I have a slope of 2 and a y-intercept of 4. So in this form, y equals mx plus b. My slope is 2x plus y-intercept is 4. Okay? What's the y-intercept? 4. Now, you knew that because in this form of the equation, you know that the y-intercept is this number here. But today you're going to learn why it's 4. Okay? So I want you to write this down in your piece of paper there. I want you to write this down. Y int question. Okay, this is the big question about y-intercept. What is y when x is 0?
1.
I'm just saying that that is the question that you are trying to answer whenever you're looking at the y-intercept, okay? And here's why. You can see x is some big number over here. It's getting smaller. The x is getting smaller, smaller, and then it hits the y-axis. X is 0. So every y-intercept in the universe has a coordinate pair like this, x comma y. You always know the x value of the y-intercept. What is it? 0. It's always 0. Okay? It's the definition of a y-intercept is it's 0. In this case, 0, 4. So what is y when x is 0? In this example, what is y when x is 0? 4. Okay, so here's how you prove that to me. I'm glad that you guys know that. Here's how you prove it. Write this down. Y equals 2x plus 4. Someone read this question to me. What is y when x is 0? So I need to go in here and I need to replace that x with a 0. Okay? Now the way I do that is going to mean everything. I'm not just going to go put a 0 there and make it look like it says 20 plus 4. I'm going to do 2 times 0 plus 4. Write it that way. What is 2 times 0? Anything times 0 is 0. So y equals 0 plus 4. Simplify the right side. 0 plus 4 is 4. So y equals 4. So the answer to our big question, what is y when x is 0, is 4. And we literally proved that. We made x be 0.
Oh my God. Is that it?
That's the y-intercept. So now we're going to move to the x-intercept. Okay? So keep that in mind. Keep that big y-int question in mind. Here is your x-int question. This is your big question for x-int. Ready? Yes. What is x when y is 0? Okay? What is x when y is 0? So I'm going to write this equation again. This was my equation. This is what we've graphed. Y equals 2x plus 4. So I want to know, someone read this again. What is x when y is 0? So I'm going to make y be 0. So 0 equals 2x plus 4. Now how do I solve? I want x by itself. What do I do? We've been doing this for weeks. Minus 4 on both sides. I got 2x equals negative 4. Now what? Divide both sides by 2. Cancel out the 2's. Okay, what's x? X equals negative 2. Okay? So, that means that in this equation, the x-intercept is negative 2 comma 0. Your y-intercept is 0 comma 4. Your x-intercept is negative 2 comma 0. You understand? We're going to do some more. It's okay. So, here's the good news. If you can master this, where you can solve for the y-intercept and make sure you know how to plot it on a graph, and you can then play this little game and solve for the x-intercept and plot it on a graph, and if you can identify the slope of a line, those 3 things, you can do 95% of all the problems on the STAR test. Okay? Those are the only 3 things they're ever going to want you to do. Slope, x-int, y-int.
That's it?
For linear equations, that's it. So I'm going to go ahead and erase all this. Can I erase all this? And I'm recording, so it'll be available. Let's do another one. Here's our new original equation.
Let me write that.
Yeah. There. Okay. Y equals 2/3 x minus 4. Where we're gonna go through this together, okay? We're still working together. First of all, we can just read the y-intercept off of this equation. What is it?
Oh, -4.
-4. What's the slope?
2/3.
What's the rise?
2.
What's the run? Okay. Now what we're going to do is we're going to go to our piece of paper that we got.
Okay.
Go to your piece of paper.
Roll it.
Everybody needs to take their protractor. Okay? Everybody take your protractors. Just use whatever side of the page you can. Okay, guys, please stay focused. I need you to model focus because I am recording this.
You edit.
Draw a vertical line.
What number? 5 to what number?
1, 2, 3, 4, 5, 6, 7, 8, 9. We'll make it 10 lines long. Okay? Now, flip your protractor like this and make sure you're lining up that blue line right there and draw a horizontal line like this. Just make that picture on your paper, okay? Now go around the edges of the graph and put arrowheads. Okay? And then label the vertical axis Y and the horizontal axis X. Okay? Now, very important, okay? Watch. You see these lines here?
Yes, sir.
Those lines are not what we're going to use. I want you to take your protractor and turn it vertically. Now look at this 3. Let me zoom in on this. Okay? Does everybody see this long line next to the 3? Center it until it looks like it's disappearing over the horizontal line. And then turn your protractor so that it is perfectly parallel to that vertical y-axis with just the tiniest little bit of space. This takes a little bit of finesse, guys. You're going to have to mess with it a little bit. You see how mine is wrong? There's a little bit too much space, and then it gets narrower. I need to turn it just a little bit like this. There. That looks better. Good. Now, here's what I want you to do. Look at all these little tiny lines. Let's make sure we're only listening now. No talking. Look at these little tiny lines. The smallest lines are 16ths. Then the middle lines are 8ths, and then the kind of the taller lines are 4ths. We are going to go up a 1/4 inch at a time. So we're going to go up by 4ths. So you're going to go to the tall lines and put a dash. Every tall line like that. Dash, 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 dash. Don't move the protractor. Now go down. 1, 2, 3, 4, 5, 6. Okay, just like that. Does yours look like this? Now, what you're going to do is spin the protractor like this. Okay? Now we're going to center that 3 line. The center line there, we're going to center it directly over the vertical axis. And now we're going to make sure that we are just perfectly spaced along this ridge. Okay? Now we're going to do the same thing. Every 1/4 inch, that's these, we're going to put a dash. Make sure you're using the same spacing. That's what's important, is that it's the same spacing. Otherwise, it won't work. Be precise. Okay? Now, take a minute and number everything. So the origin is 0. Put a little 0 there. This is 1, 2, 3, 4, 5, 6. -1, -2, -3, -4, -5, -6. 1, you only have to number 6. 3, 4, 5, 6. -1, -2, -3, -4, -5, -6. Make sure yours looks like that. Now, let's graph this line. Y equals 2/3 x minus 4. Y'all watching me? Let's go down to the y-intercept of -4. Okay, that's where we're going to put a dot. And that's my y-intercept, okay, y-int. The coordinates at that location are 0, -4. That's the x, y right there, okay? Now, what's the slope in this problem?
Oh, 2/3.
So I go to the negative 4 with my pen or pencil. And then I rise up 2 and I run to the right 3. Now, we are going to be so precise that I'm actually going to come in here and put in some guidelines. Okay, with my pencil.
We have to do.
You got to do it. Okay? This is all about precision. You want these lines going right through those tick marks. So it actually takes a little bit of getting used to. Do the same thing vertically and horizontally. You're basically creating graph paper on this piece of paper. Okay? So, you said up to over 3. Up 1, up 2, over 1, 2, 3, right there. So go ahead and plot that second point. Tell me the coordinates right there. It's x comma y. What are the coordinates right there? Good. 3, negative 2. So 3 comma negative 2. I want you to go put your pen there on that point you just plotted and go do it again. Go up 2 over 3 from that new point. Ready? Up 1, up 2, over 1, 2, 3. What are the coordinates right there?
0.
X comma y.
6, comma 0.
6 comma 0. Very good. Remember our big question about the x-intercept? What is x when y is 0? Well, this is x comma y, people. So y is 0 right here. What's x? 6. So we're going to come in here and draw our line. Make sure it's going through those 3 dots perfectly. And if you drew this right, then it will. It will go right through the x-axis at 6.
Sorry for the interruption, but let me get these students to the library at this time. Nehemiah Stephen, Angel Delgado, Madison Hatton, Ethan Frederick, and Kayla Lewis. Maya Stephen, Angel Delgado, Madison Hatton, Ethan Frederick, and Kayla Lewis to the library. Thanks.
Okay, so now we've drawn the y-intercept over here. Okay, remember it was at 0 comma 4. The y-intercept answered the question, what is y when x is 0? And then we've drawn the x-intercept over here, which graphically we've answered the question, what is x when y is 0? Now you're going to algebraically prove this x-intercept. So let's move down the page a little bit. And let's write y equals 2/3 x minus 4. Okay? Y equals 2/3 x minus 4.
It was like a figure
Now this is your homework. Okay? Now, what do? What do you replace that y with? A 0, because you're trying to answer the question, when y is 0, what is x? So 0 equals 2/3 x minus 4. Now do your math the way I taught you. Draw this line so you don't mess up. And how do we solve this?
Plus 4.
Plus 4 on both sides. Cancel. Here 0 plus 4 is 4. Equals 2/3x. Multiply. Yeah, we're dividing both sides by 2/3, but in reality, we're multiplying by the R word. Reciprocal. So we're multiplying both sides by 3/2. So on the left side, it would do you well to remember that 4 is really 4/1. Now look, you can cancel out everything on the right side except the x. So the x is all by itself now, equal to. Now look, be smart. What's 3 times 4? So we have 12/2. What is 12/2?
6/1.
6/1. And what does that reduce to? Look, what is 3 times 4?
12.
So it's 12. It's 12/2, right? Now reduce that fraction. 12 divided by 2. It's 6, right?
That's what I said, but people were looking at me like I was.
12 divided by 2 is 6, yes? So we're just going to put 6 equals x. Hey, there's no coincidence, people. Look over here. Graphically, you already found that x was 6. Do you understand what you're doing? You graphically find it, and then you algebraically find it. So all this time, hey, we're almost done. All this time that you've been solving for x, you've really been locating a place on the graph. You've been finding where a line crosses the x-axis, okay? And so this is how you prove that the x-intercept is 6. Okay? Now, for your homework, you will finish the 4 problems at the bottom of that page. And all you have to do is solve, just replace the y with a 0 and solve for x. Replace the y with a 0 and solve for x. Staple that piece of paper, pass this around, staple that piece of paper to the back of your packet.
Can I staple it tomorrow? Because I need work. I have to pay it side by side.
Yeah, that's what I do.
Okay, then just put your paper inside your packet and we can staple it tomorrow. Okay.